Hi all, I am Jeff Johnson, Assistant Professor of Department of Mechanical Engineering, Rajagiri School of Engineering and Technology. I am here to present the subject Metallurgy and Material Science. The introductory part will be discussed in this session. We can see nowadays, every day, we are interacting with one of many materials. There are plastics, wood, metal, non-metals, ceramics. If you look into detail about these materials, we can find every material has its own characteristics, its properties. What is the reason for this variation of properties? That has to be investigated. So after this, when we get to know about this material structure, you can see even from that basic level of the material structure, that atom, basic unit, that itself creates a difference in the characteristics or properties of the different materials. The atomic structure, atomic bonding, atomic interaction, etc. gives you a direct relation between the characteristics of a particular material as well as the atomic interaction. How those things pave the way for melting point characteristics, then mechanical characteristics, likewise. So very properties or characteristics are interconnected with this sort of structure, bonding, as well as interaction. So when we go through the history of materials, that's milestones of progress, you can see the different ages that we already passed by. The Stone Age, Bronze Age, Iron Age, Concrete Steel Age, and polymers came into existence, plastic, likewise, and Silicon Age, semiconductors, then Information Age that we are normally, usually we are going through those age period. So you can see initially people were living in caves and they were using stones as their weapons. Later fire was discovered and it was one of the significant discoveries in the human civilization. The later part of it, several metals were discovered, copper and gold, those metals to be discovered. Then materials started to process, annealing, shaping. Simply means we can change the properties of a material by properly carrying heat treatment. Because if you heat a particular material, its properties changes, its characteristics changes. It's atomic, if you consider from the atomic structure, starts changing when you heat that particular material. So after that, if we cool that particular material, then we can cool it that by water, oil, air. Likewise, there are several methods to cool it. So each and every method gives you different characteristics for the same material. So that is the way of heat treating the particular material that we discussed when we reached to that particular topic. Then later, in almost 4000 BC, you can see the melting and casting of metal started. So people started melting the particular metal, then poured it into a mold, which is simply the cavity. The cavity will be as same shape as the final product. The later part of it, people started reducing the metals from its ore. You can see pure form metals cannot be extracted out of it. So there will be ores that are easily available in the nature. So we will extract the metals out from this ore. For example, bauxite or aluminum can be extracted likewise. Then later, alloys were discovered. It's a combination of metals. Suppose we are taking an example for aluminum and zinc. So we will mix it together with some calculated proportion. So we will get finally an aluminum zinc alloy. Example, bronze is a mixing of tin and copper. So likewise, the different characteristics of various metals can be incorporated together to get a new metal, new material, simply a new alloy. So likewise, there are several processes happened in the human era. So what was the need of advanced materials? So if you consider the strength and density with respect to the materials being used from years, so we can see initially wood and stone were the major materials being used. Then through the Bronze Age, people started using bronze for several kind of applications. Cast iron, steel. Steel is one of the major metal used in structural applications. Steel. Then later aluminium was discovered. Aluminium, if you compare steel with aluminium, aluminium has lower strength, but the density is lesser for aluminium. So if we can incorporate any sort of reinforcements along with aluminium, certainly we can bring changes. We can bring changes to the aluminium matrix. So we can bring that aluminium to a stage where the strength will be similar to steel, but the weight will be less as well. So such kind of researches are going on. So because of the discovery of the several materials like steel, aluminium, and composites, different types of composites are there. Aluminium metal matrix composites, copper, nickel, then polymer metal matrix composites, ceramic composites. There are several types of composites are nowadays in use, and it is being used in a wider way, so that we can say aerospace industry, automobile industry, in every industry these composites are made use of. So because the fuel efficiency need to be higher in such sort of applications, so automobile or aerospace, so we can reduce highly concentrated or densified metal with such kind of composites. So thereby we can we could get the strength as that sort of material like steel, but its weight will be considerably less. That strength to weight ratio. So that will be there for the composites. The aramid and carbon fibers composites are nowadays being used widely. So these are so we need more materials, advanced materials, and without compensating the requirement of strength. We need strength in several applications, but how to reduce the weight or the stiffness? Specific stiffness can be increased by using these sorts of composites. So we can see, if you consider automobile industry, these are the materials being used. You can see 68% of materials used in automobile industry is that of ferrous metals. The later non-ferrous metals are used: rubber, plastic, polymers. Likewise, so what is the difference between ferrous and non-ferrous? We can see ferrous, iron content will be there. In the case of non-ferrous will be having no iron content. For example, non-ferrous aluminium, copper, tin, likewise. So steel, likewise, there will be iron content. So ferrous metals are being used in larger extent in the case of automobile industry. If you take the aerospace industry in consideration, so here, because aerospace industry need much lighter metals, so they will use aluminium as major constituent. It's one of the non-ferrous metal. They also use different types of composites: steel, titanium. Later we can see people started carry out research on aluminium composites, polymer metal matrix composites, and these sort of composites are nowadays being used widely or larger way in the case of aerospace industry. We can see communication and entertainment. Even if we can say the technology has upgraded, even if the technology has to be bring together with the help of materials. There are several materials. You can see glass materials, polymer composites. The different types of materials have been used in order to make that product so beautiful like this. So materials are giving such sort of finish likewise. So there are different various types of materials are available, even and also applied in communication and entertainment industry. Then classification of materials, you can see these are the various classifications: metals, ceramics, polymers, composite materials, semiconductors, biomaterials. So if you consider these sort of materials on the basis of the density, you can see metals are having higher density, and showing, you can see platinum having higher density than silver, copper, iron, titanium, aluminium, magnesium. And then the next set of materials, ceramics, zirconium dioxide, aluminum oxide, silicon carbide, silicon nitrate, glass, concrete. So this sort of materials will be the next category. Then after that, the polymers. You can see polytetrafluoroethylene, polyvinyl chloride, polystyrene, polyethylene, rubber. So these sort of polymers are there. You can see the very lighter materials compared with the other two. But it could be used in several applications. If you consider water flowing through a pipe, there is no requirement of a metal body to manufacture such pipe. So we can use only PVC. So that itself will meet the requirement. So then composites, glass reinforced composites, carbon reinforced composites. So these are the sort of composites having much lesser density, much lighter compared with this. So this sort of materials can be applied. And nowadays, various sort of researchers are also going on this particular area. So material science, if you take as a whole, so there is a processing way of making these materials. Then there is a structure. After processing, we will be provided with the structure and its properties. If you check the properties, that will be different from the initial one. And we are processing those materials together in order to get better properties, thereby better performance. So if you consider an example of aluminium, and if you mix with aluminium oxide, that is one of the ceramic particle, or silicon carbide. So finally we will process it, that is, we will mix it, these two powder particles, and then later we can see the structure will be different. The structure will be different from aluminium, as well as structure will be different from the silicon carbide as well, because we are making it as a combination of both this. And the properties will be different. So suppose the hardness of aluminium is say number 50, that will be increased by 55 or 60 because of the inclusion of the hard particles like silicon carbide. So ceramic particles means inorganic compounds made of nitrides, oxides, carbides, etc. So this is a simple structure. It's a simple way of explaining it. The structure will be changed by the processing method. The properties will be changed, and this whole tree will be directly is connected with the performance of the material finally. So the performance is very important. Finally, it's not that just sake of processing it. We will process it into a material where we can apply it in several fields, even structural applications. So there we need more load carrying capacity, like sort of thing is required. So this material science tetrahedron will be giving you that idea. So this material science is being used by the several streams. So we can simply give a summary. This material science is an interdisciplinary area where many science and engineering streams merge together. Suppose we take an example of a mask manufacturing. There are several materials, but it is directly related to the medical field. But those people who are working in the side of the field of material science certainly can help those medical personnel. In order to develop a mask, this could be very much useful, because material science is such a stream, so it's having wider application. So we can see physics, chemistry, maths, geology, biology, medicals, engineering and technology. So it is an interdisciplinary area. And then what is the difference between matter and material? So matter, we can see it's a broad word that applies to anything perceived or known to be occupying space. Solid matter, gaseous matter, vegetable matters, like this. Material is usually means some definite kind, quality, or more specific, especially cotton material, explosive material. So it's made up of some material. So material has been some kind of quality or quantity of matter that especially is intended for use. So engineering materials is considered to be a wide variety of materials available which have shown their potential in various engineering fields, ranging from aerospace to even household applications. The bowls that we are using, there are different types. materials have been used, aluminium, steel. The materials are usually selected after considering their characteristics, specific application areas, advantages and limitations. So these are some of the ferrous metals which have iron content. Non-ferrous metals don't have any iron content, aluminium, magnesium, copper, nickel, titanium. The plastics, thermoplastics as well as thermoset plastics are there. Ceramics and diamond, composite materials, the nanomaterials, so that material powders will be in nanometer range. So you can see some of the images that clearly gives you an idea how much level of imaging can be made possible from the material structure. So you can see some of the structures that is from the insect. Through the naked eye it will be not possible to see such patterns, structures, but we are having certain microscopes which are having higher resolutions. So even atomic level images can be captured. So we can see the surface of the shark. This is a grain structure as well as a microstructure is available. So we can easily identify these kind of structures and how it is helpful for that particular creature to live. So that's kind of biomimicking can be also made possible by studying that microstructure and artificially making a material in such form. That is also possible. So we can see the nanometer level of microscopy, that is imaging is possible. So hydrogen atom, only one electron. So this is a photograph shows the atom's electron orbital. So first time we have ever been able to observe the wave function of an atom. To capture the image, scientists used a quantum microscope, a device capable of seeing into the quantum realm. So this is the periodic table that already know. So we can see the different set of elements classified on the basis of alkali metals, alkaline earth metals, transition metals, other metals as well as non-metals, halogens which are having higher electronegativity, noble gases are simply inert gases which are more stable, exact stable elements in the periodic table. Then rare earth elements that is provided in the lanthanide series, cerium, neodymium, likewise erbium, polonium. So these are kind of rare earth metals and actinoid elements. So this all comprises of a periodic table. So if you consider the Earth's crust as well as universe, hydrogen is 73% in universe and helium, then oxygen is surplusly available in the Earth's crust. These are the several kind of naturally available elements. So what is the importance of atomic structure and bonding? The characteristics of materials is friendly on the basis of the atomic bonding and its interaction with different atoms. So atomic structure determines the type of bonding, and bonding decides the properties of materials as well. So how the bonding will be there in between the atoms? So if you take an example of graphite and diamond, both are carbon allotropes. So carbon bond covalently in the plane, carbon and carbon bonds covalently, but we are having van der Waals forces between the layers. There are several layers for the graphite structure. So the layers will be bonded together by the van der Waals forces. So that is the reason it is soft. Layers can slide relative to each other. In the case of diamond, the carbon atoms are covalently bonded to each other for other atoms. So it will be type of a hardest material, one of the hardest material. So metals have weaker metallic bonds. The metallic bonding is there. Ceramics having stronger covalent or ionic bonds. Simply means two types of bonding, primary bonding and secondary bonding. The bondings like ionic bonding, covalent bonding as well as metallic bonding comes under the primary bonding, and van der Waals bonding as well as hydrogen bonding comes under secondary type of bonding. So secondary type of bonding will be much weaker when we compare that with the primary bonding. So it's a simple thing that you're already familiar with. An atom consists of a nucleus, which will be having proton and neutron. Neutron is neutral and electrons will be orbiting around it. Then proton is a positively charged particle, neutron is a neutral particle, electron is a negatively charged particle. And atomic number will be same as the number of protons. An atom is electrically neutral. That means negatively charged particles will be same as, the number will be same as positively charged Number of electrons will be equal to number of protons. Then charge of an electron will be minus 1.6 into 10 raised to minus 19 coulomb. Atomic mass. Atomic mass is mass of protons along with the mass of neutrons. Since even if the electrons are there, its mass is considerably less, we can neglect that mass. It will not be having an impact on the atomic mass. That is the reason why an atomic mass unit AMU is given by 1 by 12th of atomic mass of carbon, 12. So carbon will be taken as a reference. We can see 1 AMU per atom is same as 1 grams per mole. So 1 mole of a substance will be having 6.023 into 10 raised to 23 atoms. Suppose we take an example of iron. That is, atomic weight of iron is 55.85 AMU per atom, or we can say 55.85 grams per mole. Now we can look into this is the simple atomic structure, the basic unit of the cell, and there will be bonding between the two adjacent atoms, interatomic connections, interactions, etc. has to be studied, and those topics will be discussed in the next session. Thank you.